Swayam Prabha. Digital India. Educated India.
Hello everyone, and welcome to this demonstration of a few things which we are going to do. The first one we are going to see through these two softwares, ArcGIS and ArcView, that is buffer creation, how buffers differently can be created, and we will also discuss in between during demonstration how these can be utilized. And second demonstration which we will see in this discussion about the attribute classification in GIS. So, these two main discussions or demonstrations we are going to have through softwares. So, in ArcGIS, what we are having one point file which is a soil samples, just as this will be using for creating buffers, and we can choose a field or some other fields or many fields together. Where you would find this tool in this particular software is in geoprocessing. So, when you go for this geoprocessing, there is an option which is called, first option is called buffer. As I have been saying, whenever you use any software, whenever help comes, at least first or second times you must read that information. So, like here it is saying geoprocessing tool that creates buffer polygons around input features to a specified distance. In our case, the input feature is input feature is our point data. All right. Now, once we go, then there will be a new window will come, and there we have to declare few things before we go to create the buffer. So, first which file? So, I am going to take this soil sample file here. If more than one file, one theme is displayed, then there will be a list. If single themes are displayed, then there will not be any other option. Now, after this we will go for where to keep the data, that is the output feature class that will come very soon, and then we will have other details request. And like here, so whatever it is in default it is creating, no problem, we will go about that. Now, here linear units, these are in our mapping units, and mapping units as you can see are in degree decimal. So, these are in decimal degrees, and therefore, we must take care while creating buffer about this units. It has to be in the mapping units, whatever the value you provide in mapping unit. Suppose I am giving 30 here in decimal degree in the mapping unit, and then what I am going to say that I want a no dissolve type initially. I can do like this, and in next round we will do a dissolve type and then see what is the difference between these two. Basically, dissolve, when we go here, dissolve type, as you can see that if we choose none, then an individual buffer for each feature is maintained. And when we say that dissolve all, then all buffers whichever is having overlap will be dissolved. So, time being I am just going for the default, that is none, and let us do this buffering. It may take some time, and then we get a buffer layer as per the given units or distance. So, around these input points, buffers would be created having this 30 decimal degrees linear units, which are not which are quite big in that sense, but depending on your requirements. I have just taken one value, and I deliberately I am about to create a big circle, so they become obvious and visible to in this demonstration. See here now these buffers around each point has been created. But since we have chosen option not to dissolve, and therefore we see that there are many buffers around many points which are overlapping to each other. So it is for real analysis, we need to resolve or dissolve these boundaries of individual overlapping buffers, so that we get a good real picture. As you can see that here a large overlap is there. So in the background we are seeing the 6 buffers, and top of those 2 buffers are there. In next processing, what we are going to do, we are going to create buffers with dissolve. So and the rest of the things we will keep as it is. So I have taken that one, and here I am again taking 30 units, and here only the option which I am going to change, that dissolve all. All buffers are dissolved together into a single feature, removing any overlap. So now there will not be overlap in these things. It may take little more processing time, because not only it has to create, the system has to create buffers around each point, but later on it has to dissolve those buffers as well. Now here what we are seeing now, these dissolve buffers. So the buffers earlier and these dissolve buffers are having quite good difference. So if I give a different color to the previous one, and if I bring top of this one, you can visualize that what I am talking. So here what you see, that it looks more realistic. But suppose if it would have been, this is about the soil sample data, and if this would have been a different thing, like if suppose it would have been a network of mobile towers, and around the each mobile tower, suppose buffer has been created. Now by doing this thing, we would know immediately that there are gaps in that area where no mobile signals can reach. So such kind of analysis can be done involving buffers very easily. And what I am going to do, I am going to overlay the previously created buffers top of this, so you can see that what I am talking basically. See, these red circles are showing those overlapping buffers, but the new buffer which has been created is without any overlap, and all has dissolved. So it looks more realistic and more useful than without overlap. So this care must be taken. Now there sometimes there might be requirement of creating multiple buffers around a point. So this can be done very easily in ArcView. Also I am sure it must be done, it can be done in ArcGIS in multiple stages. But at least the tools which are visible to us does not allow us to create multiple buffers in one go. Though in multiple go, obviously it can be done. So what we will see, the same data file we are going to take in ArcView, and here also we have to add an extension, buffer wizard, and this will allow us to create buffers and you know. So now this create buffer option is there once we have set the units. Now what we are going, it's a wizard. So wizard means that basically these are sequential processing, and much easier way you can do it very quickly. So of course it is asking that what is going to be your input file. So we are seeing, since in our view we are having only one file, so automatically is there. It is also declaring that there are 74 points. So should the number of features selected, should I create buffer on selected points or on all? So since selection is 0, and therefore it is going to do on around all input points. Now once we go for the next, it asks a few things, that what is the specified distance. So suppose if I give a specified distance 20 here, because we are going to create multi-field buffer, and here I would like to give a field here, say for example pH, and then we can choose for multiple buffers also. So multiple buffers if I do, then also, so first we can go for say this kind of buffering, that giving 20 meters in distance, and can create buffers likewise. There is some issue, the number you and okay, this exercise we do for basically and let's do it for multiple buffers. For that purpose only we were doing, and multiple buffers we are keeping here, instead of 1000 we are keeping here 3 and 10, and of course it is in meters, and this will work. We can keep little larger value since it is asking, so no problem. Now again that should it be dissolved? So we say yes, it should be dissolved. Either you can store as a theme or you can store as a graphics. So we will do as a graphics. Later on you can convert as a theme also, and we finish it. Now here buffers should have been created. Now see, the buffers have been created, and if we zoom, because it depends on the units, you know. So if we zoom, we should be able to see, like here, see buffers have been created like this. So around different points we can create buffers, multiple buffers also, and some better, more practice would be required to have a full control over these softwares. Otherwise in one go you can create multiple buffers. In like here we could do it multiple buffers just for few points, but if we want to do it for many points, again we can try and run that one, that here, and then here I choose a field like this one, and then say okay, again problem about the distance. So okay, maybe little larger distance we give, and then multiple buffers, and we are going for a new theme. Again multiple buffers have been created around each file. Depending on what distance we are giving, it will be your multiple buffers around each input point which you are seeing here. So each point is having multiple buffers, as because earlier we have created 3, now giving the different possibility we have created 3, so there are more now buffers have been created. So multiple buffers can be created. What is the use of multiple buffers? That if we know that something gets disperses with distance like pollutants, then we can create some multiple buffers, though they are having little harder boundary, So in order to have a more softer and realistic boundaries, what we can do, we can first create a surface using interpolation techniques, create the buffers, and for buffers we can extract from the background layer, that is a interpolated layer, and we can get a very smooth circles, multiple circles showing the conditions which might be there and or would be there. So it depends on which application you are trying. Then as per that and depend on distance, these circles or buffers can be created. I have taken the most simplest vector feature, that is point. Similarly, the line features or polygon features can also be taken, and around which the vectors can be created without any problem. So this is how the buffers can be created. Now what we will do, we will also see one more thing here, that is the classification of attribute data. So what we are going to do here, we are going to add one file which is a raster file, and we'll try to perform this classification. So here the classification is going to be on raster data. Similarly, you can do also on the vector data as well, there will not be any problem. Now here this file which I have added is a digital elevation model of the same area where we were handling the soil sample data. Now this is, for time being, is displaying in a continuous fashion because it is raster, so it's a continuous data. The lowest value is 1489.33 and highest value is 1532.21. This much information we are having. But if we go for this classification, then as discussed in the theory, we get lot of options here. And this also, as I told you, when we have been discussing classification of attribute data, at that time I told you that there are about there are 7 types of classification techniques which have been implemented into GIS, including that manual classification technique. So where we get these options, when we go for this and symbology, first layer properties, then symbology, and then when we choose this classified, then we get option about the classification. So when we press this one, what we get here is a histogram. As I was saying, that the histogram should be studied first before we choose any kind of classification. So see the distribution of the these cell values between this within this digital elevation model are varying. It is not a well shaped. Generally, it is true that most of the data sets may not show the distribution in well shaped. So therefore, there are now options are there. By default, in this particular software, it always go for the natural breaks, which is based on the this Jenks optimization. Though the one which we have discussed first while discussing the types of attribute classification was equal interval. Though manually we can also define intervals, manual classification is also there. Then after equal interval, we also discuss quantile. Then we discuss natural breaks. We also discuss statistical base, that is standard deviation, and geometrical interval. So any of these methods of classification can be chosen. By default, it always do it in natural breaks. So suppose if I go and say do it equal interval. Here I can decide how many classes I would like to create. By default, it is giving 5. I say I want 7. Now as you see that when I have chosen 3 classes, it is showing that this, because it is equal interval, so it will cover all the distribution of cells between having this range into one class, then next and then next. If I choose 7, then there will be these 6 vertical lines dividing the whole histogram into 7 categories, 7 classes. And the breaks are going to be like this, break values, it is going to be like this. Now I can also choose a percentage or a normal one. So I do not do any further thing. But before that, you can, if you want to see the standard deviation of this input data, then you get immediately by choosing that, or you want to see the mean line is here, and that is giving your further information. So, study of histogram will make us understanding of the distribution of the data within a one file will make us to choose most appropriate classification method of our attribute data. Here in case of a raster data, which is a digital elevation model which I have taken, is a continuous, and therefore it will have only one attribute, that is the cell value or elevation value here. Here also you get the simple statistics including standard deviation, mean value, sum value, minimum and maximum and total count, everything is there. So, if I classify this one in using equal interval and 7 classes, this is what the result I am going to have, as you can see. Also during discussion I said the colors do not matter in GIS. What really matters, the value of the cell or attribute of your feature or your object, that may be point, polyline, polygon or a raster. So, here the by default it is the gray ramp has been chosen. We can choose some other colored ramp also, like this one I can choose, and then say OK. So, if I say OK, then I get this thing very without any problem. Now, if I change my classification method, instead of say using equal interval, if I say I want natural breaks, I will keep in this exercise, I will keep all classes 7, total number of classes to divide in 7, and then say OK. And when we say apply, let us see what changes it brings. Here you have to focus in this part. So, what, see, slight change it has brought. Now, what the point was here for discussion is that different classifications should create always different results, but all this will depend on the distribution of the data or that statistics, simple statistics we are seeing. It is not necessary that all classification will produce all distinct differently results, not necessarily. It will depend on the. So, if we now this time if I choose some other classification like standard deviation, and I say there will be only 5 classes, this option is not open then. So, 2 in minus side, 2 in positive side and 1 is in center and the mean one, and then when I say this one and apply, see it has completely changed the appearance of my classified map. So, if this map is satisfying my needs, I can accept this classification as well. But one important thing which I would like to highlight here, that there is no change in the data. This is what the word manipulation comes in our discussion. But we are manipulating only with the classification and trying to display new things on screen. But the real data is intact all the time. There is no changes whatsoever in the real data. So, the 6 rather here you see the 7 options, but defined interval means this is also manual one. Here I can and defined interval or equal area, I can choose equal interval, you can define also, or manual where you want. So, manual you can also choose. So, by which depending on your requirements you can choose a classification technique. Like here I have just chosen geometrical interval, and when see this the distribution, this is based on also frequency. So, the width of classes here is not same. So wherever the values are having less frequency, the classes are wide here. The distance between these two blue lines, vertical lines, is big here. Whereas wherever you are having more frequency, then it is less. So it is basically also in frequency area based kind of thing. And when we go and say okay, classify, just focus on this one, the entire appearance will change. Nothing has happened to the data, only for our visual inspection things have changed. So different classification methods can be employed not only on the raster data sets but on vector data sets as well. As you choose the theme accordingly, this will be done very easily. But the main point here is that one has to keep in mind that before choosing a classification, this I am repeating again, before choosing a classification, first study the histogram. That means the distribution of your cell values, pixel values or other values. Once that you have understood, then you would get some idea that which classification method you should adopt. Simple statistics will also allow you to go through that one, and then you choose appropriately the classification method and number of classes as per your requirement, and then you can go and perform the classification. It should produce desirable results. Now suppose in this one I have found that geometrical interval is giving good results, but that does not mean that if I am having another set of data for maybe same area or different area, the same classification method having 7 classes will give the same kind of results. May not be necessary, because it depends on the distribution of the data. So that is why I am emphasizing again and again that histogram, its simple statistics will let you know that which is the best way of doing classification. Otherwise methods are available, nobody will tell you that which classification method you would. But whenever we go for equal interval, which is the most simplest one, many softwares are having in general in the default, but that is not very scientific in sense that what is the basis of classifying everything in equal interval, because it should be classified based on certain statistical or distribution or shape of histogram and likewise. So, but sometimes even equal interval is adopted just for simplicity. People easily understand definitely equal interval. They understand equal interval classification method more easily than any other, because first they are seeing how things are distributed, and what you are seeing here, this will become also part of our legend. So they do not want to see, they will see the colors and try to relate things with the map and the legend. So as I mentioned, that equal interval is the most popular or most easy to understand, but sometimes for many types of analysis that may not be most appropriate. This we also discussed while discussing the theory part of attribute classification. So this basically brings to the end of these two demonstrations about buffer and classification. See, the theory generally is will tell you what are the things, what are available and how things are done. But when we come for implementation or application or using some softwares, then various options are available to us. Like when I was saying about buffers, you can create multiple buffers, you can create multiple buffers in ArcGIS also, but maybe not in direct one go, but in multiple go. So nobody, basically there is no instructions or nobody will tell you that how much rings you should create, how many buffers you should create, what should be the distance among these buffers. So all this, when we come for the real practicals in our projects or studies, these things have to be decided by ourselves. Softwares are providing tools to us. software tools to us, a set of tools, hundreds of tools. Which tool to use when? This would depend definitely based on our requirements. And once you know that what my targets are, then you can decide how I can achieve my targets or how I can process that data which will create my or which will satisfy my targets or my higher ups in the system. So, for that there is no straightforward thing, but in theory things are straight that I have discussed. There are 7 types of classification one by one, and advantages, disadvantages, like thing. But here when we come for the real practical things, then I cannot foresee or can tell you that which one is the best, not at all. It will depend as per your requirements, one, and in particularly in case of classification, it will depend on the distribution of the data. So, with this I end this discussion or demonstration. Thank you very much.